Okay, so now let's talk about the properties of the Taguchi design. Fractional one, okay? So we have to make sure that everything is all right with our design. The first thing is that we have to have each level of each parameter that should appear the same number of times. Second is that you have to have the minimum number of repetitions of parameters. So we'll talk about this one as an example. Orthogonality is that we have to test all levels of the parameters. So let's go back and then see one example. So the first thing is that we have to check whether it is proper or not. First thing for being proper is that so each level should appear the same number of times. So let's see. Factor 1, level 1 appears twice, level 2 appears twice, level 3 appears twice, level 4 appears twice. Or factor 3, level 1 appears twice, level 2 appears twice, level 3 appears twice, level 4 appears twice. So it means that the first condition of being proper is okay. So this one has passed the test one. So you can also check for factor 2 and then you will see that it is proper. Second thing, that whether it is proper or not, let's see that. Okay, for second part is that we have to minimize repeating the parameters. Okay, so let's see what it means. So, for example, when the run is, let's check run 2 and then run 6. Okay, so if you check run 2, you have the level 1 of factor 1, level 2 of factor 2, level 3 of factor 3. If you go 6, you have level 3 of factor 1, level 2 of factor 2, level 3 of factor 3. So, in this case, what it means is that so when B or factor 2 is at level 2, okay, so factor 1 is at 1 and then 3, so you check. Factor 3 is at 3 and then 3, okay, which is violating the rule number 2, because rule number 2 says that you cannot repeat the parameter levels. So when factor 2 is at level 2, factor 1 is not repeated, it is 1 and 3, but factor 3 is repeated twice. Or vice versa, you can say this way as well. When factor 3 is at 3, factor 2 is repeated as 2 and 2, which is the violation of the rule number 2. Now let's come back to the last one, which says that all levels of parameters should appear. So let's check it. Orthogonality. Okay, so in this one, for example, we have, so for example, when factor 1 is at level 1, okay, factor 2 is at 1, factor 2 is at 2, but we cannot check 3 and 4. So at 3 and 4 missing. Similarly, when factor 1 is 1, factor 3 is at 1 and 3. So factor 3 at 2 and 4 missing. So we don't test it. So it means that this is not orthogonal. You can also check for other combinations, like when factor 2 is at 4, We check factor 1 at 2 and 4, but we don't check 1 and 3. We check 2 and 4, but we don't again check 1 and 3. So we don't check all levels of the parameters. Let's see one more example here. So first thing is that we have to check whether it is proper or not. The first test, we have to have the levels appearing the same number of times. So A1 appears twice, B again twice, 2 appears twice, 2 appears twice, 3 appears twice, 3 appears twice, okay? Or 4 appears twice, 4 appears twice, and 4 appears twice. As you can see that it is okay. We have passed the first part of the test. Now let's come back to the second one. For this one, you have to check whether you have a combination, something like this one. Repeating levels, okay? So let's come back here. So for example, when factor A is at 2, factor B and then C are at 3, 4, 3, 2. It is not repeated. Or let's check for factor 4. When it's at 4, A is at 4, 2, it's not repeated. C is at 2 and 4, it's not repeated. Okay. But if it was something like 2 and then 2, you can see that when B is at same level, C is repeated, okay? Then it would be the violation of the rule. But in this case, no. That's the reason that we will just say that it passes the test. We can check for other combinations as well. Now let's proper, it's okay. Let's check whether it is orthogonal. So to check orthogonality, you can see that when is A at 1, B is at 1, 2, C is at 1, 4. So we don't test B at 2 and then 3 and then C at 2 and then 3. That's the reason that this is not an orthogonal. You can check for other parameter levels as well. So then we will talk about the problem solution using fractional factorial.